Hello everyone. Welcome to our lesson 2.1, Approximating Measurements. So for our objectives for today, we will approximate the measures of quantities, particularly length, mass, volume, time, angle, and temperature. So I'm sure that this is not your first time. You can always relate on how important measuring is when you try to wear your clothes, when you try to transfer a liquid from one container to another, or even when you try to fit your shoes from the mall. And most especially, we really love this one. We try to estimate our time of travel from one place to another. And perhaps the last thing that is very close in our situation right that we're in right now, we would love to know our body temperature, whether we have a fever or not. So, how do we define measurement? So, measurement is actually a process of comparing an unknown quantity to a standard known quantity. So, there are three keywords here to easily understand the meaning of measurement. So, there's a word comparing, then the statement unknown quantity, and standard known quantity. So, what are we referring to the statement unknown quantity? So, these are the different quantities that we usually measure, like length, mass, capacity or volume, time, temperature, and angle. So, later we will try to recall your lessons in grade school on how do we define the different quantities. So, for each of the unknown quantity that we have, so of course we need to compare it to a standard known quantity. So from each of the unknown quantity, we have standards. Like for example, for length, common standards are the following. So we have inches, foot, meter, and cm. For mass, whatever is unknown, we try to compare it to the standards for pounds, kilogram, gram. And for capacity or volume, let's say you want to know the liquid that you can pour into the to a bottle, you can compare it to a standard known, which can be either pint, cups, tablespoon, teaspoon, liter, or milliliter. And for time, this is not something new to us. We usually use it every day from one time to another. So we have seconds, minutes, hours, days, week, or month. Then for temperature, we have Fahrenheit, Celsius, and Kelvin. And for angle, for now, in when you deal with basics, you will be dealing with degrees only. So based from what I've said, the standards are actually divided into two systems. So it can be either from metric system or from US customary or English system. So how do we differentiate the two systems? So let's talk about US customary or English system first. So this is actually based on the British imperial system. Its units evolved from non-standard units of measure in medieval times. So if you were able to listen carefully from our TED Ed video, you were able to realize that during medieval times or during the start of time, we usually use non-standard units like comparing it in our human body parts or some materials around us. So, for example, some materials before like wood, kernel of corn, and alike. So, from time to time, it already evolved. There's a standard already given to us by British imperial system, and that becomes our US customary or English system. So they originally coming from those non-standard units. So if you notice one common unit for US customary is, for example, the foot. So the foot is literally coming from a measurement of a foot of a person. So that's it. So it's really coming from this non-standard units. While for the metric system, it's actually in the later part, because the metric system is more on multiples of 10. So as simple as that. So the idea is coming from multiplying a 10 or dividing a 10, and you get the measurement. So in Philippines, we are actually following the metric system, and it is the only system of measurement prescribed by law through Presidential Decree number 187, enacted on May 10, 1973, which was superseded by Presidential Decree number 748 on July 16, 1975. So eventually, a law to this effect, Batas Pambansang Bilang 8, was enacted on December 2, 1978. So we are actually following metric system, and together with the majority of countries around the globe. But for USA, for example, it's one out of three countries who are still following the US customary or English system. One of my research says that they're still using it because it somehow um, give them a standout from other countries, that they're superior from the other countries as well. So that's one of the reason. But as I said, there are only three countries who's using US customary, but the rest of the countries are already using metric system, and the reason for that, it's easier to convert or to use it because it's just a multiple of 10, unlike English system, since it's originally coming from non-standard. So there's no consistency in terms of the measurement, or there is no pattern at all when you try to change the unit to another. But in 1960, this is during the French Revolution time. So again, going back to the video you have just watched, during this time it's already French Revolution, and they demanded a standard wherein it will be beneficial for scientific studies. So during this time or this year, there is an international agreement regarding specific choices of metric units to be used in scientific measures called as International System of Units, or SI units. So what is the reason why um, there is an agreement during this time? As I said, it's more on scientific findings. And of course, when you try to discover something, it's not just a day or a week. It will take years just to discover something. So for us to make sure that whatever will be discovered or whatever will be measured from this year, um, so that we will be able to save time, we will have to use consistent unit of measurements. So by the time that, for example, 10 years from now, you have your study but it is not yet successful, so that the future generation will be able to save time and they will not go back to the very from the very from scratch. They will be using your study, and since it's not successful, they will not be doing that again, but they will serve that as an inspiration to come up with a new hypothesis, and try to test some try to test the new hypothesis. So that's perfectly the reason why. It's really more on the archive part. So here are the SI units. For mass, it's kilogram. The abbreviation is kg, and the length is meter. Time is seconds. Temperature is Kelvin, and the amount of sound substance is mole. The abbreviation is mol. Electric current is ampere, or A. So if you notice in your batteries, that's triple A, double A, because that means it's ampere. And then luminous intensity is candela, or abbreviation is CD. So of course, from your grade school lesson, to have an accurate measurement, you have to use an appropriate instrument or device. So this is just a recall for you. So how do we define measuring tools again? These are devices used for measuring the physical quantity that we are looking for in our definition, the unknown quantities. So from the act of measurement, you can actually get the exact measurement with a number and a unit of measure. So when you use the tool, for sure there's a number to it, plus the unit of measure matters. So for length, just a recall, when we talk about length, we're measuring the distance. The basic unit again is meter. So we use a meter stick. Okay, so probably 1 meter stick is a meter. And we have ruler. It's a smaller version of a meter stick. You have inches and cm on different sides. Later, we will be discussing inches and cm. And for construction, most of the time we use tape measure because we need longer measuring tool for for those situations. In laboratories, of course, we're measuring small objects or species. So we have the caliper and micrometer. For mass, so when we talk about mass, it refers to the amount of matter contained in an object. So the basic unit is actually a kilogram for bigger quantities, but sometimes if it's a smaller quantity, we use gram. So the tools that we usually know are the following. For sure, you're already familiar with this, the weighing scale. But in our present time, you already have the electronic weighing scale. For laboratories, we usually have the triple beam balance scale. And in our clinics, we have the analog weighing scale. Third is capacity. So when we talk about capacity, it's the amount of material needed to fill a container of a certain size. So the basic unit is a liter. So in laboratories, again, we usually use a graduated cylinder. And then for baking or cooking, we usually use a measuring cup. And we also have our standards intended for teaspoon, tablespoon. The tool to be used for that would be the measuring spoons. For time, I think time is understandable, but we define time as a continuous, measurable quantity in which events occur in a sequence proceeding from the past through the present to the future. Basic unit is seconds. So when we try to measure time, we have stopwatch as our tool, or even our watch, and even a bigger version of our watch, which is the clock. And for temperature, when we talk about temperature, it refers to the degree of hotness or coldness of a body. Basic unit is Kelvin. So perhaps you might be asking what's a Kelvin? What's Kelvin? 'Cause what you will usually hear is Celsius in the Philippines, and when you're in US, you usually hear Fahrenheit. So in advance, Fahrenheit is under English, so that's why you'll be hearing that unit of unit for temperature in US. But for Philippines, we're again following metric, and that's Celsius. But for Kelvin, it's usually used for scientific studies. So you will be dealing with that more on your science laboratories. Okay, so what are the different tools used when you measure temperature? So we have thermometer. So it can be a room thermometer or a clinical thermometer. And then the last one is angle. We will talk about more on this topic on third quarter under geometry. But the tool to be used for the measurement of an angle is a protractor. Um, you will be using this soon, the protractor. Okay. Now, our actual lesson begins here. So let's say, for example, you go to Bohol. Okay. Aside from the picture that you see right now, which is the Chocolate Hills, Bohol is known for tertiaries. So if you've been there, actually when you go to, of course, no, when you go to a site where you see tertiaries for public viewing, you of course that's during daytime, and tertiaries are nocturnal, so you don't usually see them running around because they are actually hibernating or sleeping during that time. So of course we don't want to scare them, so you cannot just simply touch them or go near them. Actually, one of the rules there is you have to be quiet. So you just have to really watch them from a distance. So, of course, when we would want to know the measurement of a tertiary, how tiny it is, we cannot just go near it and use a ruler because we were asked by our teacher to measure a tertiary. So, what we usually do, though we are from a distance, we have a skill called as approximation. So how do we approximate? So when we say approximation, it's actually you are actually giving a rough estimate, but not necessarily the exact value. But of course, it has to be near to the exact value. So instead of using the equal sign, there is a symbol for approximation which would look like an equal sign, but it's not straight. So it's like this. So this symbol is pertaining to approximation. So we read this as approximately equal to. So again, the meaning of this, it's not the exact value, but it's near to the exact value. So just say it as an educated guess. So you're not just guessing out of the blue, but it has to be educated because it has to be near. And you have basis for it. And that's what we will do right now. We will practice on how to do educated guess or proper approximation, even if we don't have the tools with us. So for length, of course, we will begin by comparing it to the objects that we usually see. So for example, a bee. A bee, I think everyone were able to see a bee already. So a bee is approximately 2 centimeters. So when you try to measure an object, um, let's say a chair, you try to compare it from a bee. So how many bees do we need just to reach the tip of one chair to the other tip of the chair, from one tip to another? Okay, for 5 centavo coin, so this time it's a smaller object compared to a bee. So we will not be using cm anymore, but instead we will be using millimeters. So a 5 centavo coin is a 15 millimeters. Then a 1 peso coin is 2.5 cm. Then the back of a chair is approximately 1 meter. So as I said a while ago, 1 meter thick is 1 meter. So if you put the meter stick at the back of the chair, that would probably be approximately be 1 meter. And then a giraffe is around 5.8 meters. So thinking about the chair that we have, it's 1 meter, approximately 1 meter. So it's like saying around 6 chairs piled up. So that will give us the height of a giraffe. So as you see in the picture, we are referring to this, okay, the height. So that's around 5.8 meters. So 6 piled chairs. And since we're talking about two different systems, so the ones that I've mentioned a while ago are the common units under metric system. These are the common units for US customary. So for example, 1 inch, the inch there is actually coming from an actual thumb. So the thumb knuckle, if you're not aware what's a thumb knuckle, this is the thumb knuckle. So thumb knuckle to the tip of your thumb, that's 1 inch. Then, of course, the most common unit for US customary is the foot. So just imagine an adult foot. That's approximately 1 foot itself. Okay, going back to the video that you've watched, the only issue that we have during the medieval times, during Egyptian period, um, the problem of having foot as a unit before the actual foot. People have different sizes of foot. That's the reason why, from time to time, they've come up with a standard on what would be 1 foot. So commonly, it's coming from a king or someone from higher up as a basis of those standards. And then 1 yard is actually from your nose going to the tip of your middle finger. So that's 1 yard. And then the distance that you can walk in 20 minutes is approximately 1 mile. Okay, for mass, peanut is approximately 1 gram. So if you compare a snail from a peanut, if a peanut is 1 gram, so approximately you need 200 peanuts. And that gives us the weight or the mass of our snail, which is 200 grams. And then a banana is 100 peanuts, so 100 grams. And for a pineapple, so approximately it's 1 kilogram. Okay, for saltwater crocodile, that's approximately 500 pieces of pineapple. So saltwater crocodile is approximately 500 kilograms. Okay, now those are the units, common units for metric system under mass. This time we'll talk about the common units under US customary or English system. So one slice of bread is 1 ounce. And then one loaf of bread, okay, just try to imagine. I think you can have 12 pieces of 12 pieces of slice of bread to come up with one loaf of bread. So that would be 12 ounces. Okay? But approximately one loaf of bread is 1 pound. And then a walrus is 1 ton. Okay, for volume or capacity, okay, A drop from a medicine dropper is approximately 1 milliliters or ml. And then a small can of milk is 120 ml. So that's 120 drops of from the dropper. Then a calibrated cylinder has a capacity of 300 ml, but it depends on the calibrated cylinder. But the ones that I am showing right now has a capacity of 300 ml. And then a bottle of Coke is 1 liter, but I guess you're familiar that most of the bottles of Coke now from 7-Eleven or from a department store, the plastic one, it's 1.5 liter. But the bottle, like the bottle which is breakable, that's 1 liter. Okay, now let's proceed to temperature. So a normal body temperature when you're not sick ranges from 36.1 degrees Celsius or 97 degrees Fahrenheit to 37.2 degrees Celsius or 99 degrees Fahrenheit. Okay, now the freezer in your refrigerator, the temperature is usually 0 degree Fahrenheit or negative 18 degrees Celsius. And then Metro Manila average temperature during summer is 26.6 degrees Celsius or 79.9 degrees Fahrenheit. And then boiling water is 100 degrees Celsius or 212 degrees Fahrenheit. Okay, for angle, okay, just remember that an angle would look like this one. We will not be talking too much on how can we define an angle, but it looks like this. If it's like an L, the angle measurement is 90 degrees. So the symbol for degrees is like a circle here, just like this. And then, so of course, if we try to show an angle which is half of it, half an L, that's half of a 90, so 45. Then, if you see a straight line, the angle measurement is actually 180 degrees. So that means that if the angle would look like this one, this is between one straight line and a 90-degree angle, which is an L by the way. So that's half of it. So that's 90 plus half of the other 90. So that's 135. Okay, now let's practice. Which is a better estimate for the weight of a coin? 5 grams or 5 kilograms? So the answer is 5 grams. So the answer cannot be 5 kilograms because, as you see, kilograms would be um, quite too much. Is too much, by the way. So from what we have discussed a while ago, 1 kilogram is one pineapple, and I think you were able to hold a coin already, and a coin is not as heavy as a pineapple. So that's it. So when you try to approximate, you compare it from something that you know. Okay? So, and in addition, just to add on something from our lesson from first quarter, from first quarter, 5 is equal to 5 no. But when we do measurements already, having the units will make it not equal. So not necessarily that 5 is just equal to 5 when we have units already. So 5 grams and 5 kilograms. Soon in our second part of our lesson, we'll discover that 5 grams is lighter than a five that lighter than 5 kilograms. Okay, let's continue to the second question, which is a better estimate for the weight of a DVD player. So A, 4 kilograms, B, 4 grams. So the answer is 4 kilograms. So we're not talking about the disc, but the player itself. So the DVD player would probably be 4 kilograms and not 4 grams. So I know that 4 is equal to 4, but from what we have discussed a while ago, one pineapple is 1 kilogram. And gram, you can compare it to a peanut. So 4 peanuts. So that is not as heavy as a DVD player. So 4 grams is too light. So the answer would probably be A, not the B. So question 3, which is a better estimate for the volume of a cereal box? A, 3 liters, B, 3 milliliters. So the answer is A, 3 liters. So not 3 ml, because from what we have discussed a while ago, one drop from a dropper is 1 ml. So therefore, yung 3 ml natin, tatlong drops lang. And I don't think that 3 drops will, you can fill in the entire cereal box with it. So probably the most convenient estimation here is 3 liters. Okay, let's have question 4. Which is a better estimate for the volume of a dose of cough syrup? So A, 12 milliliters, B, 12 liters. So the answer is 12 milliliters. So 12 liters would be too much. So just imagine 12 bottles of Coke. So yung mangyayari, if you will drink 12 liters of cough syrup, probably it will lead you to overdose. So that's too much. So probably just 12 ml, 12 drops of liquid from a dropper. Okay, question 5. Which is a better estimate for the weight of a microwave? So A, 18 grams, B, 18 kilograms. Okay, the answer is 18 kilograms. So 18 grams would be too light because that would be 18 peanuts. Okay, next. Which is a better estimate for the height of a coffee mug? 18 kilometers or 18 centimeters? Okay, the answer is 18 centimeters. So when we talk about kilometers already, remember that um, that would be more on distance from one building to another. So just try to imagine that one place to another. So probably kilometers. We usually use it kung if we travel from one place to another. So just think of that. Okay, I don't think so the coffee mug would be as big as 18 kilometers. Okay, next. Which is a better estimate for the weight of a light bulb? So A, 36 kilograms, B, 36 grams. So the answer is 36 grams. So 36 kilograms would be too heavy for a light bulb. So remember, a light bulb, you can just carry it in your hand, right? So I think you have bulbs at home. So, which is a better estimate for the volume of a salt shaker? 32 liters or 32 milliliters? Okay, the answer is 32 milliliters. So of course, salt shaker would just be very light, not as heavy, not as many as 32 liters. So just imagine 32 bottles of Coke. So that would be quite impossible for a usual volume of a salt shaker. Question 9, which is a better estimate for the weight of a DVD disc? So A, 9 grams, B, 9 kilograms. Okay, the answer is 9 grams. So this time we're talking about the disc and not the player. So the disc would be very light. Question 10, which is a better estimate for the weight of a pizza? So 1 kilogram or 1 gram? So the answer is 1 kilogram. So it would be impossible it's just 1 gram because 1 gram would be equivalent to 1 peanut, and I'm sure a pizza would not be as light as a peanut. So probably the wisest choice would be 1 kilogram. Okay, question 11. Which is a better estimate for the volume of a shoebox? So 4 milliliters or 4 liters? Okay, the answer is 4 liters. Shoebox would be quite big, right? It's a rectangular prism. So having 4 ml would just be 4 drops, and that will not fill in a shoebox. So probably just 4 liters because it's possible that we have 4 bottles of Coke and then we try to transfer the liquid going to the shoebox, assuming that there's no hole in the shoebox.